Hi, I'm Brad Henry with Landell Controls and Shelley Automation, and in this video I'm going to show you how to perform defect detection on a shiny metal thread using a Cognex camera. Before I get to the camera, I need to start with the lighting. Since this object is circular and shiny, there's special considerations need to be taken. So, got my threaded item down here, and surrounding it I have diffuse lights with polarizers and a coaxial light in front of the camera, also with a polarizer. The lights are diffuse because this object has a mirror finish, and it would reflect the image of the LEDs of the lights back to the camera. That would give some noise and produce a poor image. I'm using a coaxial light in front of the camera so I can shine a diffuse light straight down and cover all the area in front of the camera. I tried this with a ring light. It did not work as well because the hole in the middle of the ring light was a lack of light and it showed up as a slightly darker spot on my image, so ring lights won't work. I'm using polarization because a polarized light has a orientation, a structure to it, and when a polarized light ray hits a mirror object, it reflects back in that same orientation, the same structure, and it passes through the polarizing filter in front of the camera lens. Light that is reflected or scattered loses that structure, and if it makes it back to the camera, it is filtered out by the polarization filter. So it basically makes the edges sharper and highlights what we're looking for, which is anything that's not a well-looking thread. And this is what a thread looks like. You've got your crests and troughs and the areas in between in this thread shape. When light hits a trough or hits a thread, it reflects straight back, and this is what the camera is picking up. When the light hits off to the side on a curve, it reflects out instead of back up, and this is a dark area here. And on some of the sides, and especially closer to the bottom, the light hits one side, reflects to the other side of the thread, and then reflects back to the camera. But each of these reflections increases the scattering and decreases the strength, so this light is less powerful and shows up as a gradient or a shade of gray rather than the white from the crest and the trough and the black from the reflection outward. So that's how it works. So let's get to the camera. So this is what the image looks like. You can see the thin white lines here are the crests. This is the trough, and these gray areas are the sides. You'll also notice that the lighting changes the farther you get from the middle of the camera, just due to the lighting and the structure. Because in this diagram, light is always coming from the top, but if light were to come from the side over, it would mess it up, and that's what's happening in this case. Okay, so let's get into the tools. I'll zoom back in here for a minute. So since these are gray, and you can definitely see a difference between the gray and the white, I was able to use a binary filter to filter that out. So now we've got these white lines here. And these skinny white lines from the crest are the only lines we're concerned about. Because if there's any damage to the thread, it's going to be to the crest, it's never to the trough, because the trough is deeper. And I'm using an EdgePairDefect tool to analyze these crest lines here. And what the EdgePairDefect tool does is it looks for defects and it looks for gaps. And how it does this is it measures the edges. So let me go down, zoom way in, show the caliper. So if you see these green lines here, these are small little edge tools, one on either side of this line, and the distance between them is measured. Each of these pink and purple lines is what's called a caliper, and it's really what it is. It's a caliper, like and it's looking for bulges where these lines are farther apart than, or too far apart, farther apart than the mean, or they're too close together, so under the mean distance, under the mean value of all these calipers, or gaps where it can't find an edge at all. So let's see how this works here. So here everything looks good. No concerns. Let's go to a defect image. Okay, here's a defect image. You can see these damages on the top of the threads. That's what we're looking at. If I go to a binary image, you can see there's these gaps here. And let me just move the locator. See, that's what it's catching. It's catching these gaps. This failed image has a defect. You can see the bulge here from damage to the thread. If I go to the binary filtered image, this is very wide. And you can see the EdgePairDefect tool is catching this. So if I zoom in, all these squiggly lines here, these are all defects from where it's much wider than it should be. So that's it. That is how you do defect detection with a Cognex camera. I hope you found this video useful.